Hello students, this is the final section of section 5.4, Factoring by Grouping and Special Forms. Our objective for this video lecture is to be able to factor polynomials completely by repeated factoring. Our first example asks us to factor the following polynomial completely. The first thing that we want to do is we always want to think greatest common factor. So here I want to think, what does 8 and 50x squared share? So 8 I know can be written as 2 times 2 times 2. 50 can be written as 2 times 5 times 5. And the x squared gives us 2x's. So there's at least a 2 that we can pull out of this polynomial. So I'm going to change the order, and I'm going to write this as negative 50x squared plus 8. Then I'm going to rewrite this, but I'm going to pull that 2 out. And in fact, since I've now rewritten it to have the negative in the front, I'm going to pull out a negative 2. So I'm going to have negative 2 times 25x squared. And I'm going to have here minus 4. Now this is where we're really putting it all together, because at this point I have a difference of 2 squares. Now the reason I know it's a difference of 2 squares is because here I have 2 2's, here I have 2 5's, and 2 x's. So anytime I see pairs like that, and everything has a partner, I know that it's a perfect square. So to factor this completely, I'm going to write this as negative 2 times, and remember our rule for a difference of squares has one with a plus, one with a minus. And I'm going to have 5x and 2. And 5x and 2 in the back as well. So this gives me my complete factorization of this polynomial. Our second slide here has 2 questions. So let's start with y to the 4th minus 81. Y to the 4th can be written as y times y times y times y. And 81 can be written as 3 times 27, which is 3 times 9, which is 3 times 3. And here again we can see we have pairs. So we have 2 pairs of y's for y to the 4th and 2 pairs of 3's for the 81. So this is certainly a difference of 2 squares. We're going to start by writing this as a simple difference of 2 squares. For one we have y squared minus 9, and for the other one we have y squared plus 9. Now we don't have a formula for the sum of 2 squares, but we certainly have a formula for the difference of 2 squares. So now we have y squared and 9, which can be written as y times y and 3 times 3. So our complete factorization of this first question has y plus 3 times y minus 3 times y squared plus 9. So now let's take a look at our second example. The first thing that we want to think here is greatest common factor. So we have 6x to the 5th, which is 2 times 3 and then 5x's. And we have 30x to the 3rd. So 30 is 2 times 15, and 15 can be written as 3 times 5 times, and then there's 3 x's. So we can see here that we have a 2 and a 3 in each one. and we have 3 x's in each one. So our greatest common factor is going to be 6x to the third. After that, we have x squared plus 5. So we have to check our rules to see if there's any way that we can factor x squared plus 5. And in this case, there is not, so this is our final answer. So our final question for this video lecture has to do with geometry. We have the area of a rectangle whose length is L, and it's given by the polynomial below. We want to factor this expression to determine the width of the rectangle. So remember that the area of a rectangle is length times width, and we're told that this is our formula for area of this rectangle. So we want to take and we want to pull one of the L's out. So if we pull one L out, we're left with 45 minus L. So you can see this L and this L are the same. And the width has to be given by this 45 minus L. So the width of this rectangle is 45 minus L. And that concludes this video lecture.